Hello everybody. In this video we are going to introduce the use of Linq. Sometimes called the Linq directly or something called the Linq, like you have different pronunciations. But and you can actually see it right here. So I call it Linq is a language integrated query, is what it means. It's a way that Microsoft through C# are able to actually have some technologies in order to have query capabilities inside the language. So something that we knew before is we actually in the past we traditionally the queries were not typed strongly. What does that mean? When we have something like we have a query and we query the database, we do something like select whatever from I don't know dual, for example. So that you're not able to actually to get the data that it came through the query. You can actually see which fields that table has, that kind of information. So that is quick typing. So strong typing is when you can actually see something like the auto completion from C# when we do dot, and they give you all the possibilities that we can actually import here. That's pretty much the strong typing system that had it. So in the past, those queries, traditionally those queries, there are no strong typed. So Microsoft went to do that language integrated queries to it. And what it does is allow us to use, as the name says, query in the different part. Usually those queries are for ADO.NET datasets, like connection to databases. We can actually do queries through C# objects. We can query to SQL Server databases, entity framework, and everything that is enumerable. And with that, we pretty much allow us. There is a family. The traditional link queue is actually for two objects. Is this one? There is also link queue to XML, I believe. I don't remember pretty much how to import it right now, but we accept link queue to XML and link queue to SQL. The other two objects and third-party elements also have sometimes the link queue capabilities inside. But let me actually show you how it works. Most of this example actually came from Microsoft. I was looking at some examples in there that are actually really good. And I'm adapting some of those and creating other ones. So for now, you see this data source. This data source is temporal. We will use it later. So let me minimize that. So let me do a simple array. So let's have an array, an integer array. Let's call this grades. It's going to be a new. And I can actually do it like this. New, and let's put here, I don't know, 97, 92, 80, 75, 55, 43, 90 again, 70, 66, and 75. Let's just put like a bunch of random numbers in there. Well, probably you should be using something random, but well, it is what it is. Actually, I didn't like it like that, so probably I just need to do the new array thing. There you go. So we have simple array. Let's say that those are the grades for the class. I actually hope that you don't go those low ones, but let's say that those are the grades for the class. And I just want to get really quick which one who passed, and I want to see what are the passing grades. So one way to do, we can do some kind of filter. We can loop through this and verify each one of those elements, like the traditional way. But with Linq, we can actually query this array and asking, well, tell me which one are the passing ones. And let's say the passing one is bigger than 76, bigger or equal to 70, right? So let's do variable passing grades. is going to be, and then we start doing the query right here. So for doing those queries, we need to have Linq in our using statement, so we can actually do from where that statement, from where we're going to start looking at. So I will use from grade in grade, right? And we have an issue here. The query must be end with the clause. Okay, yeah, we need to finish this first. Let's put this one right here. Should be enough. And what's complaining? Well, let's finish it. So I will say from grades in grades, I want where the grade is bigger equal than 70. I want to select the grade. And I close it here. Right? So I'm saying my passing grades is, I will take the grades array. I will section each one of those because it's an array. So each element I will section as a grade. So it will loop through those. I will verify where that particular element is bigger or equal to 70. And I will select this particular data. And that's the one that I will be passing back to the pacing grades. So through that, I can just use a simple for each. And let's do var g in passing grades. We're going to do a simple console.Gridline. Actually, do a write. And let's do a simple. The grade is going to be here and a space. Let's save this. Let's try it. Let's do a simple .NET run. And you will see what happened there. We just had a list of everything that is bigger unless that 70. Right? It's a really quick way to actually query something. And that's the beneficial of this kind of element. Like it actually helps us to go through those, and it is easy to retrieve the information that we need. And this is a really simple data value. We will see more complex in a minute. So let me try to minimize this. Actually, I didn't want to minimize again. I don't know why. Well, we will use this later. But let me copy this and let me comment the first one. And what I want to do now, I want to show something different. What about if I do a list of integers? We do something like this. The only thing that changes was the data from array to a list, right? And the list using, of course, a generic collection. So using that, if I execute, I have the exactly same approach, right? We have the same exact result. Why we have the exact same result? It doesn't need it to do any kind of changes because it goes through an object that is enumerable. So by default, it's just work. So it doesn't matter what type of input data, in this case, an array or a list, we have the same result on the output. And I wanted to show you that, right? Now, as you can see, the most common cases here is getting the from, the where, at the select statement. That's pretty much the one that you needed. And you can be as complex as you want in order to have it. Something that I want to mention before I proceed is that this is actually lazy execution. What does that mean? Like, what is like lazy execution itself? Um, that means that this is not getting done until I call it right here. So until it's going to this process, this is going to be executed. So what happened is in my grades, I just add a range, and there's a range here. Let's do new integer array of, right? This works like this? Yes, okay. So let's do 50, 50, 90, 90, 90, 90, right? So I am adding more grades to the list. If I do this for each again, let me just do a simple console dot write line. Like create I can use a new line before that. So here is pretty much I have the list. I'm making the query, call it the passing grade. I go through the query, I go through that, I print it again, I change the source data, and I execute the same query, and we will have different results. If I do dotnet run, we will see that this is what it means lazy execution. Like passing grade actually doesn't have the data right there. It just have that it creates the data when it's getting executed in this for each. That will allow us, and sometimes it have some kind of different behaviors. That's why I want to mention it. Like if you change your source data and you call again that one, your output is going to be different. In this case, it's still doing bigger than 70, so that means that just the 90s grades are the one to get imprinted at the end. This is pretty much what is happening. So in order to make that a little more persistent, because that's so let's actually encapsulate all this in parentheses, and I can do a simple toList, right? So we'll create a simple list for that one, and I will see what happened in these two cases. The data is the same. Why? It didn't took account of this because when I'm making this in parentheses with a toList or to array, both of them works. I'm actually executing this query right here, and the result of the query I'm saving it here once. So that's called eager query execution, something that has happened before. And so even that the source data changed, when I reference the same one, it was already executed once. So that means that we have the same results. If we get rid of the toList, we can actually see that it's actually having issues. So let me just copy this and paste it again. I want you to have that. Let me have it something like this. And something like this. And let's just comment this out in order to not make issues. So this is pretty much, you will have both of them there, like eager execution and lazy execution. Of course, in lazy execution, information like the query could change whenever the source data changes, like in this particular case. So that's the pretty much big elements of a query. Like that's the most common one, from, where, and select. But those are not the only one elements that you can do, and that's actually not the only um, properties that you can actually go through a list. So let me just comment out what I can comment out. Let me comment out these two. I don't want the output right now. And the Gridline too. Let's comment that out. And I will uncomment my data source. This data source is really simple. I have a products data and a customers data. So let me show you the products really quick. So I have my data class. My data class pretty much is exposing the list, product list, and customer list in a method, right? Of the type of that particular, the same type of that list. So I can actually just get that information the way that I need it. And for example, the product list is actually, I have the class product in singular. I have a product ID, product name, category, unit price, and unit in stock, like inventory, right? Probably you could be a lot better than the previous video, but it's something like that. And then the products in plural is just a list of product in singular with a bunch of data there that I took from Microsoft, actually from an example from Microsoft. So all that information is right there. And we can see it, and there is like a loader. So it's pretty much, it's like a database, pretty much. That's why I call it data sources. And customer is something similar that I will show later. So that's pretty much what it is, right? So we have the products that get product list and the customers to get customer list. And let's keep those like that for now. Let's actually go, no, let's keep that one, it doesn't matter. And let's do a new execution here. So we know that let me just show you like the console.gridline. I can see my products is let me get the first elements of my products. So you will see what it is. I have the toString also change it. So there you go. Dotnet is product is the product number 1, name chai, category beverage, unit price $18, unit stock 39. That's pretty much right. So that's pretty much the list, and if we do for each, we will see that information for all those products. I can actually do products that count to see how many there are. And we have a list of 77 products in there, right? That's pretty much what it is. So let me just remove this. Actually, we don't need that. So we can do something like this. Like we can actually get like, give me the sold out products. Let's call this, yeah, products. It's going to be something from the query, right? So we do from P in products, and let's do where P dot, as you can see, this is what I mean with strong typing, that we can actually see the information. We say, okay, units in stock is equal a 0. I will select the product itself. And I can go through the list to show which are the sold out products. And I have the example right here. Let me just paste it. Probably faster. This came from Microsoft too. If I execute it, you will see that these are the 1, 2, 3, 4, 5 different products that are actually sold out. Right? Why? Because unit stock is equal 0. If I do unit stock equal 10, another product that have 10 in stock is the one to show up. I don't know if we have 10. Yes, we have 2 of them in there. So you can actually see Actually a really complex list, go through the process and get like a inner child elements inside that property are the ones that got executed and showing out that kind of information. Now, as a traditional statement, we can actually do several elements in the where statement. And let me copy this one. So we have the expensive in-stock products. That means that products in stock is bigger than zero and product unit price is over 3 millions. With that, we just do a simple Gridline again. And let's execute it. And we have first the units in stock. Let me just go out here. Sorry, the sold out ones. And then in here we have in stock products that cost more than 3 millions. Okay? So that's rare. And we have that list over there. So we're able to have a more complex query using these kind of elements. And that's the beneficial of Linq. We can actually be as complex as we wanted, and we can have different elements. Now, we can have something like this. Customers have a more linked data. And let me actually show you. So customer, what it is a customer class. So we have a customer ID, company name, address, we have a bunch of information. But then we have an array of orders that is an order class, right? So that order class is simple order ID, order date, and total. So we have a nested array, let's say like that, inside this property. And then and then we have the list of the customer that is actually executed. Sorry. So let's go to program again. And let's check something else. Let's get the customer from Washington. We know that we have that element. So let me just go here. In customer, we have address, city, company, country, customer, order. That is, we know there's an array, phone, postal, right? So let's actually get the region equal a Washington, and I will select the customer. And what I want to do to the customer is something like this. Customer from Washington and the orders. So I just go from every customer, I will print it, and then for that particular customer, I can loop again inside the order because I was saying before, those orders are actually an array. If I execute that, we'll see something like this. Of course, the order is a little indented, so you will see that the customer, the name of the customer, and then the list of the orders, the name of the customer, and the list of the orders that they have. So you can actually print that information in this element. And it's pretty neat, right? So this will allow us to actually have a little more complex data, do a for each in a sequence properly on a traditional query. Now, we can actually do another kind of element, and we can actually do what we can do. We can transform the select. So let me just get this example from here, right? What I'm saying from the numbers, I will select the number plus 1. And when I go through that loop, I will say that actually 6, 5, 2, 4, 10, etc. will be listed there. Let's execute, and we can see it like that, right? The number, I went through numbers, and I just do a particular element. Now, this is true that something that we can do with select. So far, we pretty much selecting everything, but we can be specific too. Let me remove the guidelines. Well, I'm keeping all that because I will share the code with you so you can actually review it. And I will share the source when I took it from Microsoft too, so you can actually see that too. There's a lot more examples in there. So let me go to the products again. So we can do something like that. Like getting all the products, and I want to select only the product name. Like we can actually select a specific object here. We're selecting everything that is from the number here. We are selecting a specific property. That one, of course, will give me only the product name without the rest of the information. Right? And we can do several elements, and we can actually do matchings. Let's comment this out again. And this other template is actually really cool. So we have an issue because we're using the same name. Let's comment this out. So we have two arrays. Every array has the same size. So I will select n in the numbers, and then I will select from my strings that particular element in the index. So as you can see, the numbers are all mixed in different order, but the letters, like the words, are actually in order. That means that the first element that will come, it will take the string number 5. That means that will return 6, I believe, is going to be the word that will return it. Then go to the 4, that means that it's going to be the word 5. Then the first, that go to the word 1, things like that. So let's execute this. And we have an issue. What is the issue here? I still have something. Oh, yeah, I comment this out. I need to comment this out too. There you go. Let's execute. As you can see. Now, it's actually selecting a second array, but with a different order because we specify that one through here. So we can actually transform everything through there, and it's pretty neat. It's actually really helpful in how we can actually do things here. Now, we saw the projection operator that is pretty much the select, and we saw the restriction operator that is pretty much the where. But we can actually have partition. Those partition operators are take, skip, take while, skip while, and we can actually do simple things like, I will not go that deep through here, but we can do something like this, for example. Then comment this out. Let's use the same numbers on the top, and it will take 3. That means that we'll take only 5, 4, and 1. So take 3 is another element just to have that, and we can do something else like do this as a skip 3. This one, instead of taking 3, it will just skip the 3 first, and then we'll get pretty much the rest. It give me this part of the array. Right, we have the take and the skip pretty much working there. We can have nested skip partition, so we can actually do several things. Let me comment this out just not to mess up something. Let me comment this out too. Let's actually change this to take. This is how we had it. Let's go here and let's do what we can do. This is a little more elaborated part. Let me execute it before I explain it. So here what I'm doing is I get my customers in customers and my orders in customer orders. Then I will select everybody from Washington, and I will get only customer with the customer ID, the order ID, and the order date. That's it. So we have some kind of nesting here. So remember that orders are an array inside customer. So imagine the data being a little more complex. Here what I'm doing is, well, for every order, just put me the customer ID on the left, and it's what we are actually having here. Example, trade have 3 orders, WHITC have a bunch of them, and we can see it like that. When we know in our data that orders doesn't have the customer ID. Customer ID is an object, or is a property, sorry, that is before actually that is outside the order. So customers have that array. So we can able to do that kind of implementations. That's a little more complex in the way that we wanted to put it. Now, not only that, after we have that, we can actually skip severals, even though this is nested, right? So let me print the orders first. So you will see all of them. And you will see that Linq is there. But when I skip those two, in here, this assignment, he will not appear anymore. And that's pretty much how it works. So we have a combination of different link queues. And that's the beautiful part. You don't need to do a really big selection statement like sometimes we have in store procedures in a database, like getting information from here, from there, and a subset, a subquery, and exposing it, and then use it as a reference. And we finish sometimes in the database with a query for 100 lines, right? In this part, we can actually do mini queries and then executing sequentially. In this case, we have a query that is with from to from, that is a little more complex, but then we have a second query that we apply a skip on top of all this. And we can nest those the whatever level that we wanted, and that will allow us to see a little more, have a better control and a more readable information. Of course, all of this we have what other type of options can we use? We can use order by, for example. So in this case, we order it the TW. We have the order ID in order. Yes, it's in order. Oh no, it's not. So we can actually wear that one. And let's do something else. Let's do order by. And we can do order dot order ID. And we can do descending, or we keep it like that and it's ascending by default. So here we see 105, 108, 102, 103. So it's actually not in order. This one should be lower now. Let's see if it actually works. Let's execute it again. And now the orders are, 104, 105, 106, 107, 108. Yes, 109, 110. Now the orders are actually, the order ID is in ascending order. And we can do the descending to see now that this one, actually this one, should be on the top. Then 10904, because we will need to skip 2 with this section. Let's see if it works. There you go, 10904 is the first order that we have, because we skipped the first 2 in the descending order. Yeah. So you can be, as I've said before, as complex as you wanted, and even, as I said before, you can use another operation. So if you transform this to a list, you can actually do a reverse method that you can do a full reverse if you wanted, or you just go through a descending order by different elements. And if you want to order by other things, you can actually do order by ID, and let's do and comma order dot, I don't know, order date. So you can actually order the query by different properties. So we have the from, we have the where, order by, select, skip, take. And there's another one. We have even joins. And let me show you a simple join here. And we can do more complex in those. Let me look at a good example for the grouping operators. Yeah, probably we can use this one. Let me get it. Let me remove the control Gridline. And let me paste it. So here, I have a list of numbers. Well, sorry, an array of numbers. And from those array, what I'm having is I'm getting all of those, and I group in whenever it is divided by 5 into G, and I will sort the mode, and then with a reminder is a G key, and the number is going to be G. Now, what that key mean? And what is this selecting that is weird? This is actually a tuple. And here we're saying we want to get something called reminder, and we're going to get the G key. It's a grouping element, and the key is actually an I grouping element that we have it over there. And the number is just G, that is the official number that is taking it. So what we're doing for every number in the number groups, we're actually having the reminders divided by 5. And we can do something like this. Let me execute it. And we'll say numbers with a reminder of 0 when divided by 5. And then we do for each, with a reminder of 4, with a reminder of 1, reminder of 3, reminder of 2. So we're keeping this reminder, this grouping result in a G variable that we're able to actually use it through here. So when we get to the numbers, that is the key that we're exposing over here, and probably this is getting confused. Let me change this to X to show you. X, X, and X, right? Here what I'm doing is the number groups, I'm checking every element as an X, and this X element will have a reminder object and a numbers object. The reminder will be pretty much the result, and the number will be, the number will be the result, as we can say over here, and the key will be pretty much the, how can I say it, the other way around, sorry. The reminder is the key, and the numbers are the ones that fill up in this particular grouping. It sounds complex, but we're able to do a little more like that, and you will be able to see more benefit in those. Let me do another grouping and show you that result too. So here we have several words, and we are getting those words and group by the first letter, right, into G. So that means that the first letter we will start with the letter B, for example, and in theory, because we are grouping by the first letter, we just get blueberry and banana in there. And then we have the C for chimpanzee alone, and cheese, sorry, and then A for abacus and apple. Right? We're telling it group by this element and save that grouping as a G. When we go through those, we can actually see it like that. Letter that start with a B, letter that start with a C, and letter that start with an A. Those pretty much the one that we have here. So let me comment this out. I've been recording this for almost 40 minutes. Let me grab out. And I will show you I'm trying to show you the most common properties, and the usage will be whatever we need it, right? So we saw pretty much a lot of them. We can actually get, for example, the first of the tail, last of the default, things like that. We can have quantity like any, all of them. We can have aggregator like, because we can group, we can actually do sum, the result, sum of something. So we can do something more simpler like this. Like have the numbers and give me the sum of those numbers. As simple as that. And with the sum, we just see that instead of going through that, I have like a temporal variable that is keeping the result, and then you return the result. What we're doing in the past, we just call the sum. That we pretty much take each element and add it to the previous one until we have the official or the last one right there. Something that we can do. Also, as I said before, you can actually nest those whenever you need it, right? So, what type of benefit we can have with some? We can actually like count the characters in a list, something like this, right? This we have three different words in array, and we will sum and we will send it that in a lambda function. We are retrieving the length of every word, and then now that we have the length of every word, we're summing those, and we have the total characters using in an array. Imagine the traditional method to retrieve that is it's a lot more complex, but with Linq it's simple for us. So let me just execute it to show it, and you will see that there's 20 characters in total. A simple one-liner in order to have everything there. So I will grab out the video right now. I think we had enough. And we're able to get different elements. We're able to select them, go order, and there is another operators that we can use. And we're missing something like, I don't know, compute and aggregate elements, for example, or compare to sequence, or do some combined sequence, for example. We can do like a lot of stuff. And I will give you the Linq documentation. You can actually read the book. They have a lot in there. It will be more detailed, but I think it's playing a little more complex than it's supposed to be. I will grab out and give you the source code. I will give you the Microsoft documentation, and we have pretty much the API with all the functions that we have. And I will give you the source code for where I get all those examples. Probably you can actually read it. If you're not able to execute it the way they're supposed to, like how that one is there, is using a tool for .NET. With .NET 5, sometimes it fails a little bit, but don't worry. You should be able to go through the source code just to see the examples in there, and that should be more than enough for you. So I hope that you like language integrated queries. Really beneficial, really helpful. So meanwhile, let's do a simple npx. Of course, remember you don't have Node.js installed. You cannot do this. You can do the traditional go to gitignore.io to get the gitignore file that you wanted. Then just do git init, git add everything, git commit example finish it. I will create a repo. If you don't have GitHub CLI, you're not gonna create a repo the same way that I'm creating right here. So I will do Linq demos. It's going to be public, and I will just push it. And there you go. Any question? Any doubt? Don't hesitate to reach me. Happy coding, everybody.